Everything has its wonders, even darkness and silence. Helen Keller. What does the future look like? How will the universe meet its end? We may never be truly certain, but science has begun to paint a stunning picture of how the future might unfold. Let's take a journey to the end of time. We will travel through time exponentially, doubling our speed every 5 seconds. The vision of the future will surely evolve as we probe for more clues. But one thing is clear: the universe has only just begun. 2019, 2020, 2021, 2022, 2023. The Holocene has ended. We now live in the Anthropocene, the age of human influence on Earth's climate and ecosystems. What we do now, and in the next few years, will profoundly affect the next few thousand years. The only conditions modern humans have ever known so far are changing, and changing fast. Nothing stays the same on this planet. Everything changes. The Earth is going into one of these jumps, and you don't know what is going to be on the other side of those jumps. The Earth is always jumping. Things move on this planet. Things are not still. Everything is turning. Earth's magnetic field flips. The north and south magnetic poles reverse, a process that happens every few 100,000 years. During the transition, Earth's magnetic shield weakens, exposing us to more cosmic radiation. Comet Hale-Bopp returns to the inner solar system 2,500 years after its last appearance in 1997. Drastic sea level rise reshapes coastlines as ice caps continue melting. Low-lying islands and coastal cities face existential threats. A 30-meter asteroid impact somewhere on Earth, statistically likely within the next few centuries. The explosion would devastate a regional area with the force of multiple nuclear weapons. Antares goes supernova. This red supergiant star, 550 light-years away, exhausts its fuel and explodes. The brilliant explosion will be visible during Earth's daylight for months. The Sahara becomes tropical again as Earth's axial precession shifts climate patterns. The Great Desert blooms with vegetation and rivers, as it has many times before. Constellations begin to wander. The familiar patterns of stars that have guided human navigation for millennia slowly drift apart as stars move through the galaxy at different speeds. Voyager 1 passes a nearby star. Launched in 1977, humanity's most distant spacecraft drifts silently through interstellar space, its plutonium power source long dead. The current interglacial period ends. Without human intervention, Earth would naturally enter another ice age as orbital cycles shift our climate. A supervolcano eruption occurs somewhere on Earth. Yellowstone, Taupo, or another sleeping giant awakens. The resulting volcanic winter could last years, disrupting global civilization. A new Hawaiian island appears as the Pacific Plate continues moving over the volcanic hotspot, building new land where there was once only ocean. New island chains emerge throughout the Pacific as tectonic forces continue their relentless work of creation. Apollo footprints fade from the lunar surface as micrometeorite impacts and solar wind gradually erase the marks left by human explorers. Betelgeuse goes supernova. This red supergiant in the constellation Orion finally explodes, becoming briefly as bright as the full moon in Earth's night sky, if anyone is still here to see it. Stone monuments erode. The pyramids, Stonehenge, Mount Rushmore, all the permanent markers of human civilization weather away to unrecognizable lumps. A deadly gamma ray burst from a collapsing star somewhere in our galactic neighborhood bathes Earth in radiation. If aimed directly at us, it could strip away our ozone layer and trigger a mass extinction. Mars's moon Phobos becomes a ring. The doomed moon spirals closer to Mars until tidal forces tear it apart, creating a temporary ring system around the red planet. Saturn's rings vanish. The icy particles that make Saturn's magnificent rings gradually fall into the planet's atmosphere or drift away into space. Antarctica melts completely as continental drift and climate change transform the frozen continent into a temperate landmass. A major asteroid impact, something truly catastrophic this time, similar to the one that ended the age of dinosaurs. The resulting devastation resets the evolutionary clock. A new supercontinent begins to form as Earth's tectonic plates continue their slow dance. All the continents merge into a single landmass, perhaps resembling ancient Pangaea. The Sun increases luminosity. As our star ages, it begins to burn hotter and brighter. This is not a sign of health, but of approaching death. As it begins to run out of hydrogen fuel in its core, the Sun won't simply fade away to nothing. Photosynthesis ceases. The Sun's increasing heat and radiation make Earth too hot for plants to survive. The foundation of Earth's food chain collapses. All plant life dies. Without plants, the oxygen in our atmosphere gradually depletes. The Earth becomes a barren world. Oceans evaporate. The Sun's heat boils away Earth's oceans. Water vapor escapes into space, leaving behind a dried, cracked surface like Venus. Its core will collapse under its own weight, and the extra heat this generates will cause its outer layers to expand dramatically. All life dies. Any organisms that somehow survived this long finally succumb as Earth becomes completely uninhabitable. The Sun becomes a red giant. Its outer layers expand beyond Mercury's orbit, perhaps reaching Venus, possibly even Earth. Earth destroyed by the dying Sun. Our planet, if it hasn't already been consumed, is reduced to molten slag or completely vaporized by the Sun's expanding atmosphere. The Sun becomes a white dwarf. After shedding its outer layers, all that remains is the hot, dense core, a stellar corpse the size of Earth, but with half the Sun's original mass. The Sun is now dead, its remains slowly cooling in the freezing temperatures of deep space. The fate of the Sun is the same as for all stars. One day, they must all eventually die, and the cosmos will be plunged into eternal night. All stars eventually will run out of fuel. The temperature of the universe drops. Stars, one by one in the night sky, will turn off, and there will be no more new stars created. And so the universe will end not with a bang, but with a whimper, and not in fire, but in ice. The last red dwarf stars die. These small, cool stars burn their fuel so slowly they can last trillions of years. But eventually, even they sputter out. With the death of the last sun, the age of starlight comes to an end. The universe becomes a cosmic boneyard, strewn with remnants of dead stars. Our sun becomes a white dwarf, a hot, dense, shrunken, stellar corpse. With no fuel left to burn, a white dwarf's faint glow comes from the last residual heat from its extinguished furnace. Looking at it from where Earth once was, it would only generate the same amount of light as the full moon on a clear night. The faint glow of white dwarfs will provide the only illumination in a dark and empty void littered with dead stars and black holes. In some ways, it's kind of a ghost universe. It's the corpses, the zombie stars, that will take us into the future. Over time, gravity ejects dead stars and planets from their galaxies, sending them out into the freezing void. By chance, some brown dwarfs collide and form accidental new stars. Colliding neutron stars puncture the darkness with ultra-bright supernovae. Any surviving life forms may find refuge around aging white dwarfs. But in time, even the white dwarfs will fade and die. Stars become black dwarfs. A black dwarf will be the final fate of those last stars, white dwarfs that have become so cold that they barely emit any more heat or light. Black dwarfs are dark, dense, decaying balls of degenerate matter. Little more than the ashes of stars, their constituent atoms are so severely crushed that black dwarfs are 1,000,000 times denser than our Sun. Stars take so long to reach this point, we believe there are currently no black dwarfs in the universe. Any matter that fails to escape its galaxy is sucked into a supermassive black hole at the center. Long, dormant black holes flare up in a blaze of glory. The rotational energy of black holes becomes the last reliable source of power for any exotic future civilizations. We have a pace of life that's based on the energy available to us now. You could imagine living, conscious systems which have a very different pace and therefore can extend out, at least a lot farther than you'd imagine otherwise. You could have a living system where, if it had a thought every 10 trillion years, that would seem normal. Even if our life dies out, one could imagine at some time arbitrarily far in the future. A fluctuation occurs which allows intelligent life to exist again for a little while. So you might have islands in time of intelligence. As the expansion of the universe accelerates, it begins to spread matter apart faster than the speed of light. By this point, distant galaxies and stars are receding so fast that their light has become undetectable. The secrets of the cosmos are locked away forever. Current theories predict that atoms themselves will begin to decay, destroying all remaining matter in the universe. A proton, one of the fundamental building blocks of atomic matter, what makes us up, can just spontaneously fall apart. Any material that evades the pull of a black hole eventually dies away as its protons disintegrate. Proton decay is still unproven, and so this chapter of the future could look very different in light of new discoveries. The matter inside black dwarfs, the last matter in the universe, will eventually evaporate away and be carried off into the void as radiation, leaving absolutely nothing behind. With the black dwarfs gone, there won't be a single atom of matter left. All that will remain of our once rich cosmos will be particles of light and black holes. The black hole era begins. No planets, no stars, no lingering stellar remnants for life to cling to. Yet, even now, time has only begun to tick. On the scale of a human lifetime, the universe has just emerged from the womb. Cold, dark, and empty. This is how the cosmos will spend most of its life. Our universe gives life only a brief moment to shine, a haven in time, safe from its fiery birth and icy death. The arrow of time creates a bright window in the universe's adolescence during which life is possible. But it's a window that doesn't stay open for long. As a fraction of the lifespan of the universe, as measured from its beginning to the evaporation of the last black hole, life as we know it is only possible for 1,000th of a billion billion billionth, billion billion billionth, billion billion billionth of a percent. Black holes become the fundamental building block of the universe. A galaxy will basically be a supermassive black hole in the center, with smaller black holes orbiting it. Zombie galaxies filled with black holes continue to evolve. They'll eat each other, and they'll get bigger, and maybe they'll fall into the supermassive black hole, and it'll get bigger. The universe will still be an exciting, dynamic place. It's just that the timescales we're talking about are now trillions of years instead of thousands or millions of years. In this far-flung age, black hole mergers become the main event. Some grow to enormous sizes, possibly trillions of times the mass of our Sun. When they merge, they send out powerful gravity waves that resonate throughout the universe. Black holes can bang on spacetime like mallets on a drum and have a very characteristic song. Imagine two black holes that have lived a long life together. At the end of their lives, they're going around each other, crossing thousands of kilometers in a fraction of a second. As they do so, they leave behind in their wake a ringing of space, an actual wave on space-time. Space squeezes and stretches as it emanates out from these black holes banging on the universe. Those are the gravitational waves, and they are literally the sounds of space ringing. And they will travel out from these black holes at the speed of light as they ring down and coalesce into one spinning, quiet black hole. If you were standing near enough, your ear would resonate with the squeezing and stretching of space. You would literally hear the sound. Imagine a lighter black hole falling into a very heavy black hole. The sound you're hearing is a light black hole banging on space each time it gets close. As it falls in, it gets faster and it gets louder. Scientists used to think black holes were immortal, but even these will one day die. Now we're talking about timescales of unimaginable length, quadrillions of years into the future. On that timescale, even the black holes begin to evaporate. According to quantum mechanics, space is filled with virtual particles and antiparticles that are constantly materializing in pairs, separating, coming together again, and annihilating each other. In the presence of a black hole, one member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle appears to be radiation emitted by the black hole. And so, black holes are not eternal. They evaporate away at an increasing rate until they vanish in a gigantic explosion. Quantum mechanics has allowed particles and radiation to escape from the ultimate prison, a black hole. Black holes begin to evaporate away, erasing the last large-scale structures in the universe. As they die, they light up the darkness one by one. As the black holes slowly die off, the universe continues to expand, driven by a mysterious force we don't yet understand. This is the frontier of human knowledge, a frontier ripe for exploration and discovery. Philosophers and poets have asked the question, will the world end in fire or ice? We can now give an answer. The latest evidence shows that the universe is not slowing down. It's speeding up out of control. And the universe, we think, will die in ice, trillions upon trillions of years from now. Empty space itself has energy. In every little cubic centimeter of space, whether or not there's stuff, whether or not there's particles, matter, radiation, whatever, there is still energy, even in the space itself. And this energy, according to Einstein, exerts a push on the universe. What is the weird stuff that's accelerating the universe? We call it dark energy. And this stuff is the dominant stuff of the universe, almost 3/4 of the matter. Energy content of the universe is this dark energy, and we don't know what it is. Dark energy, unlike matter or radiation, does not dilute away as the universe expands. This has crucial implications for what the universe is going to do in the future. So what will be the future of the universe? Well, if the dark energy remains dominant and repulsive, the universe will expand forever, faster and faster and faster with time. A runaway universe. 70% of the energy of the universe resides in empty space, and we don't understand why. But we do know what will happen. If that energy continues to be there, the universe will become cold and dark and empty. That's the future, as it might be. We don't know because we don't yet understand the nature of dark energy. Until we do, we won't know the future. We won't even understand our own origins. And that's why we want to know and study this subject. Discovering the true nature of dark energy could change our vision of the future dramatically. If it somehow weakens over time, the universe could collapse under gravity. A big crunch. Given a boost, it could tear the universe apart at the seams. A big rip. Physicists increasingly suspect that there may be multiple universes beyond our own, each with their own unique laws of physics. Some would harbor the right conditions for life. Others could collapse or be ripped apart. Others still could be far more exotic than anything we could imagine. New pieces to this puzzle are out there somewhere, waiting to be found. The forecast does seem to be for an ever colder, ever emptier universe. But then, of course, we have to ask, could that end lead to a new beginning? And there are ideas whereby what actually is the end of our universe could, in some sense, lead to the beginning of a new one. Some speculate that there may be a way to escape our universe before entropy erases everything. We could create simulated virtual universes, or, with enough energy, create another one just like our own. We've worked out the mathematics, the equations. They seem to say that if you have an atom smasher that can constrict tremendous amounts of energy at a single point, you can perhaps open up a gateway, a baby universe, facing the death of everything there is. This, perhaps, is their only possibility of escape. And this also raises a very intriguing possibility, sheer pure speculation, of course, that perhaps any universe that has intelligent life in it will create baby universes, will create lifeboats, and will proliferate child universes. So, an evolution may take place among universes in the multiverse. Survival of the fittest may take place. Those universes which do not have intelligent life are infertile. They have no children. But those universes that have mild temperatures, stars like ours, would create civilizations that could open up child universes, and they would then proliferate. If there is no way to escape the universe, then entropy will march on, destroying the last remaining supermassive black holes. As the last one explodes and dies, it bathes the universe in light one last time. After an unimaginable length of time, even the black holes will have evaporated, and the universe will be nothing but a sea of photons gradually tending toward the same temperature as the expansion of the universe cools them toward absolute zero. Once the very last remnants of the very last stars have finally decayed away to nothing, and everything reaches the same temperature, the story of the universe finally comes to an end. For the first time in its life, the universe will be permanent and unchanging. Entropy finally stops increasing because the cosmos cannot get any more disordered. Nothing happens, and it keeps not happening. Forever.